125% rule applies to both the conductor and the breaker for air conditioning units. The equipment nameplate specifies the maximum current, in this case 25 amps, and maximum fuse size. The 125% rule dictates that the minimum ampacity of the conductor and the minimum rating of the breaker must be at least 125% of this maximum current. To calculate the minimum ampacity, multiply the maximum current of 25 amps by 1.25, resulting in 31.25 amps. This is the minimum ampacity the conductor must be rated for. Similarly, the minimum rating of the breaker is also calculated as 25 amps multiplied by 1.25, equaling 31.25 amps. This value determines the smallest breaker size that can be used. Now, focusing on the conductor, given that the minimum ampacity required is 31.25 amps, you must select a conductor that meets or exceeds this rating. Consulting ampacity tables for conductors, the next standard conductor size that exceeds 31.25 amps is typically #8 AWG American wire gauge. Ensure that the conductor chosen is rated for at least 31.25 amps based on its insulation type and installation conditions, referencing the appropriate NEC National Electrical Code tables such as 310.15 through 310.21. Factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable assembly will affect the allowable ampacity and may require adjustments. For the breaker, since the minimum rating calculated is 31.25 amps, the next standard breaker size above this value must be selected. The next standard breaker size above 31.25 amps is 35 amps. Therefore, a 35 amp breaker would be appropriate. It is imperative to verify that the selected breaker is compatible with the air conditioning unit and the electrical panel. Breakers are designed to protect circuits from overcurrent conditions, preventing damage to equipment and reducing the risk of fire. Selecting the correct breaker size is crucial for ensuring both safety and proper operation of the A/C unit. It is important to note that these calculations provide a general guideline for conductor and breaker sizing. Always consult the manufacturer's specifications for the specific air conditioning equipment being installed. The manufacturer's documentation may contain specific requirements or recommendations that supersede the general rules. Adhering to the manufacturer's guidelines ensures that the equipment is installed correctly and operates safely. Additionally, it is advisable to consult with a qualified electrician to ensure compliance with all applicable electrical codes and regulations. Electrical codes vary depending on the location, and a qualified electrician can provide expert guidance on proper conductor and breaker sizing for the specific installation. Safety should always be the top priority when working with electrical equipment. Before commencing any electrical work, ensure that the power is turned off at the circuit breaker. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Ignoring electrical safety precautions can result in serious injury or death. Proper conductor and breaker sizing is essential for the safe and reliable operation of air conditioning units. By following the 125% rule, consulting manufacturer's specifications, and seeking guidance from qualified electricians, you can ensure that A/C units are installed correctly and operate safely. In summary, firstly, determine the maximum current of the A/C unit from the nameplate. Secondly, calculate the minimum ampacity of the conductor and the minimum rating of the breaker by multiplying the maximum current by 1.25. Thirdly, select a conductor with an ampacity that meets or exceeds the calculated minimum ampacity, considering factors such as insulation type, installation conditions, and ambient temperature. Fourthly, choose a breaker with a rating that is equal to or next higher than the calculated minimum rating, ensuring compatibility with the equipment and electrical panel. Fifthly, always consult the manufacturer's specifications for specific requirements or recommendations. Sixthly, consult with a qualified electrician to ensure compliance with all applicable electrical codes and regulations. Finally, prioritize safety by turning off the power, using appropriate personal protective equipment, and seeking professional assistance if needed. Remember that proper conductor and breaker sizing is critical for the safe and efficient operation of A/C units. Always follow best practices and consult with qualified professionals to ensure that electrical installations are performed correctly. Air conditioning units rely on electrical power to operate, and the proper sizing of electrical components is crucial for preventing overloads, short circuits, and other electrical hazards. By understanding the principles of conductor and breaker sizing, you can contribute to the safe and reliable operation of A/C systems. The selection of conductors and breakers is also influenced by the type of A/C unit being installed. Different types of A/C units have different electrical requirements, and it is important to select components that are appropriate for the specific application. For example, a window A/C unit may have different electrical requirements than a central air conditioning system. Always refer to the manufacturer's specifications for the specific equipment being installed to ensure proper sizing of conductors and breakers. In addition to the 125% rule, there are other factors that can affect conductor and breaker sizing. These factors include the ambient temperature, the number of current-carrying conductors in a raceway or cable assembly, and the voltage drop in the circuit. Ambient temperature can affect the ampacity of conductors, and it may be necessary to adjust the conductor size to compensate for high ambient temperatures. The number of current-carrying conductors in a raceway or cable assembly can also affect the ampacity of conductors, and it may be necessary to direct the conductors to prevent overheating. Voltage drop can affect the performance of the A/C unit, and it is important to select conductors that are large enough to minimize voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause the A/C unit to operate inefficiently or even fail. The NEC provides guidelines for minimizing voltage drop in electrical circuits. In general, it is recommended that the voltage drop in a branch circuit should not exceed 3%, and the voltage drop in a feeder should not exceed 5%. To minimize voltage drop, it is important to select conductors that are large enough for the length of the circuit and the amount of current being carried. The length of the circuit is the distance from the electrical panel to the A/C unit. The longer the circuit, the greater the voltage drop. The amount of current being carried is the current drawn by the A/C unit. The higher the current, the greater the voltage drop. The selection of conductors and breakers is also influenced by the type of overcurrent protection device being used. Overcurrent protection devices are designed to protect electrical circuits from overloads and short circuits. There are two main types of overcurrent protection devices: fuses and circuit breakers. Fuses are one-time devices that melt when the current exceeds a certain level. Circuit breakers are reusable devices that trip when the current exceeds a certain level. Circuit breakers are generally preferred over fuses because they can be reset after they trip. The type of overcurrent protection device being used can affect the conductor and breaker sizing. For example, some circuit breakers are designed to protect conductors from both overloads and short circuits, while others are designed to protect conductors only from short circuits. It is important to select conductors and breakers that are compatible with the type of overcurrent protection device being used. Another important consideration when sizing conductors and breakers is the National Electrical Code. The NEC is a set of standards that provide guidelines for the safe installation of electrical systems. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC provides specific requirements for conductor and breaker sizing, and it is important to follow these requirements to ensure that electrical installations are safe and compliant. In addition to the NEC, there may be local electrical codes that apply to electrical installations. Local electrical codes are often more stringent than the NEC, and it is important to comply with all applicable codes. A qualified electrician can provide guidance on local electrical codes and ensure that electrical installations are compliant. In summary, the selection of conductors and breakers for air conditioning units is a complex process that requires careful consideration of several factors. These factors include the maximum current of the A/C unit, the 125% rule, ambient temperature, the number of current carrying conductors in a raceway or cable assembly, voltage drop, the type of overcurrent protection device being used, the NEC and local electrical codes. By following best practices and consulting with qualified professionals, you can ensure that A/C units are installed correctly and operate safely. Remember, safety should always be the top priority when working with electrical equipment. Before commencing any electrical work, ensure that the power is turned off at the circuit breaker. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Ignoring electrical safety precautions can result in serious injury or death. Proper conductor and breaker sizing is essential for the safe and reliable operation of air conditioning units. By following the 125% rule, consulting manufacturer's specifications, and seeking guidance from qualified electricians, you can ensure that A/C units are installed correctly and operate safely. Consider the long-term implications of your choices. Selecting high-quality conductors and breakers can lead to improved performance and a longer lifespan for the A/C unit. Investing in durable components can save money in the long run by reducing the need for repairs and replacements. Regularly inspect electrical connections to ensure they are tight and free of corrosion. Loose or corroded connections can create resistance, leading to heat buildup and potential electrical hazards. Routine maintenance can help prevent problems and ensure the continued safe operation of the A/C unit. Educate yourself about the basic principles of electricity and electrical safety. Understanding how electricity works can help you identify potential hazards and take appropriate precautions. There are many resources available online and in libraries that can provide valuable information about electrical safety. When in doubt, always consult with a qualified electrician. Electricians have the knowledge and experience to handle electrical work safely and effectively. Attempting to perform electrical work without the proper training and experience can be dangerous and may violate electrical codes. Stay informed about changes in electrical codes and regulations. Electrical codes are constantly evolving to reflect new technologies and safety concerns. Staying up to date on the latest codes can help you ensure that your electrical installations are compliant and safe. Proper conductor and breaker sizing is not just about meeting the minimum requirements. It's about ensuring the safe, reliable, and efficient operation of electrical equipment. By taking the time to understand the principles of conductor and breaker sizing, you can make informed decisions that protect your property and your safety. Also, remember that the information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.